Hi everyone, my name is Ostap. I'm software engineer at Grammarly, specifically in editor team. And I want today to share with you how we build design systems with Bazel, and especially like how we build a cross-platform design system with Bazel. Our agenda for today is pretty straightforward. Like we will review our problem statement, what we want to solve. Then we'll do a quick intro to Bazel, not scary one. Then to solution overview and probably some potential benefits we can get even after we did it. So problem statement. Let's start with what is Grammarly system. The Grammarly design system is an internal product that empowers the organization to produce high quality software at scale. And it consists with three pieces. First is tokens. It's actually like tokens are name and value pairs that store the foundation visual styles used to create layouts and components like red 60 equals some hex, color, and so on, like radiuses and so on. Components. Components are usable user interface elements commonly used across Grammarly products. And guidance, like the best practices, common UI patterns, and so on. What is the goals of Grammarly design system? First is a shared foundation and visual language to enable the cohesive experience. Second is to build high quality product offerings. And third, boost user confidence, trust, engagement, and retention. But how it looks like technically. First piece is the Figma libraries, where like it's a designer's world where they store design tokens and components for Figma. Then there is engineering libraries like design tokens translated to actual code for web, Windows, and Mac. And of course, the documentation and support where you can find how to install those and so on. And today we will talk about engineering libraries and especially and mostly about the web. Cool. What is our requirements for tooling and infrastructure for such kind of design systems? First, it should support multiple targets. Second is to scale indefinitely. Third is to support bitmap visual testing across platforms. And fourth, support common developer experience. And five is to generate as much as possible from Figma. Cool. Let's start from the first one. What we want to support. First, we want to support three platforms as for MVP. It should be possible to build our tokens across all of them, like color, radius, elevation. It should be possible to build components, for example, AppKit for macOS, WPF for Windows, and to React for the web. It should be possible to package all these things and push to our internal package service Artifactory. Yeah, cool. Let's move on. How we want to scale, like what we want from it. Yeah, our performance and development ergonomics should not degrade over time. Like when you add new component, it should be like only this one new component, change and build and test and so on. So for the build, we should cache component builds individually. We should cache like any icon transformations on CI. We should cache our tests, and we should also like do tree shaking and be able to preview our components on a merge request level and so on. Cool. Let's move on. Support bitmap testing across platforms. First, we want good browser support. Of course, we want Safari, Chrome, Firefox on different platforms like Windows, Mac, and Linux. Then we want a native support to be able to upload custom images for comparison. And also some nice to haves, for example, to like our service should take care of a file storage. It should not cost too much. It should have nice screenshot review UI and support our GitLab CI. First problem we want to solve is to support common developer experience. Engineers should be able to use familiar tools to contribute to our design system as easy as possible. And we see three milestones here. Like there should be great CI experience. CI pipelines should be fast. Like ideally less than 2 minutes to build, test, and deploy. Component development should be familiar also. You should be able to spin up some kind of storybook-like experience where you can change components and see how it works. and it should and external dependencies should be managed by tooling itself. So you do not need to worry how to set up Node, Xcode, MS-Build, and other tool chains that we need to build our design system. For the design tokens and Figma interaction, there's actually nothing to solve. It's already solved for us. It's called design tokens from, I guess, VCG community. You can check the link in a presentation and explore how the format looks like. We're using almost the same one, but with slight modification. You can see screenshot here. And it's actually a fully typed design JSON, since our design team was eager to learn JSON and TypeScript, and they just like write small TypeScript code to represent the tokens from Figma. Cool. How we actually build this? I'm not sure why my slide is not showing. Cool. First of all, we need to support multiple target platforms. And for this, we need to pick our monorepo tool. And as you can guess, we picked Bazel. And yeah, it would be nice if you write to a Zoom chat which monorepo tool you are using on your projects. And maybe we can then discuss in a Q&A. So yeah, we picked Bazel. We also tried NX. We tried YAR workspaces and so on. But as you can see, none of them are have native support. So yeah, let's move with the Bazel one. So Bazel have three fundamental things that we are using. First is a platform support. Bazel provides excellent support for our needs in all platforms that we are using in Grammarly, like web, macOS, and Windows. And it can scale to mobile clients like iOS and Android. Also, it abstracts the toolchain management. So Bazel can fully manage our versions for Xcode, Node.js, and MS-Build. And also, it provides aggressive caching, where Bazel allows us to cache all computations like generated icons, tokens, and reuse our cache on CI and vice versa. So very quick Bazel 101. Bazel have workspaces, packages, and targets. A workspace is a directory tree on your file system that contains the source files for the software you want to build. The primary unit of code organization in a repository is a package, and package defined as a directory containing build files. A package is a container of targets, which can be defined as in the build files, and most targets are one or two principal kinds, like files and rules. Labels are like all targets belong to exactly one package. The name of a target is called its label. Every label uniquely identifies target, like this path where you can specify toolchain, where you can specify paths to your package, and then label. And yeah, build files. By definition, every package contains a build file, which is a short program. Build files are elevated using an imperative language called Starlark, but to be honest, it's just a Python version 2 syntax, nothing fancy there. Cool. How it looks like in our design system. First, we have a workspace which has three toolchains, like Node.js toolchain, like Xcode, and MS-Build. Then our packages directory split with four things like TypeScript, Swift, C# and Java. We will go and see how TypeScript is structured. So inside TypeScript, we have tokens, icons, typography, and components. And inside tokens, we have color, radius, space, and elevation, and so on. And as you can see, all of them are individual Bazel targets. How, for example, our colors pipeline look like? So first of all, we have some target called generate colors. It uses our Node.js toolchain, and it produces some TypeScript file. We have another target called build colors, which depend on a generate colors output and produces a JavaScript file. And for this task, we are using TypeScript compiler toolchain. And how we use it, we actually invoke Bazel build, our path to our packages, and invoke the target, like build colors. And it automatically understands, okay, in order to build it, I need first run generate colors, and then I can run colors, and then I can output colors.js. And yeah, so that's how it works. How it looks like in real code. Here is like our workspace file where we fetch the rules in order to run Node.js under Bazel. We set our Node.js version, and we run our npm install. It's a part of a toolchain. Then, for example, in a colors build file, we reference our TypeScript and we reference our Node.js binary. And for example, we run our Node.js binary to generate colors, and we transpile this TypeScript file with TS project. Cool. How it looks like, how our pipeline overview looks like. First, we traverse our design JSON with TypeScript. Then we pass our JSON to TS function to produce TypeScript file output, like color tokens become color TS file. Then we collect multiple files for each token and component. Then we run TypeScript to generate React components from icons. Then we compile to JavaScript and pack everything under npm package, and then we deploy that package to our Artifactory. Yeah, and if you can see for macOS and for Windows, it's actually the same. We reused we even reuse a couple of our steps, like collect file, traverse in design JSON, but of course we using different functions to produce different files. Like we produce a color.cs file, and yeah, we like generate XAML file from SVG, but essentially pipeline looks the same. Cool. How we want to cache things. Yeah, we want to cache like per component per test, and also we want to cache our tool chains like Node, Xcode, and all that like Node module stuff. For our toolchain, we're using BuildBuddy. It's a free open source tool that we deploy to our AWS infrastructure, but you can actually ignore it and use just Bazel disk cache also. It's not mandatory to use such tooling. Okay, how caching works. So essentially, each red lines here are becoming our cache targets. So, for example, if we change our TypeScript toolchain, then we do not need to rerun our generate tokens target in order to get the file itself. We only need to run build callers to, like, since we updated our TypeScript, it might produce another version of JavaScript file. So each of these steps are becoming the cache targets. And if we are talking about, for example, our tests, it looks actually the same. So, for example, we have our component. It has some build step which produces, for example, button JSX. Then we have our tests. We are using Jest toolchain for it. And in order to run tests for it, yeah, it checks the cache first. And if file is identical, then we do not need to run tests and we can get cached output. And actually the same happens for the bitmap tests. We also depend on the file itself. And if it's the same, we never rerun the test. And it happens on each component. Just another example. For example, we have icon button, which depends on the button. And as you can see, it is the same. Like these pipelines are just duplicated for each component under the Bazel. So if we change icon button, for example, and we never touched button, we will only run build for icon button, test for icon button, and yeah, bitmap test for it. Cool. Support bitmap testing across platforms. We want to select first we want to select tool for it, and then we want to somehow inject our bitmaps from the native platforms in order to compare it between like web, macOS, and Windows. For the tool, we select Hapo. It exposes the benefits of it, that it exposes the public HTTP API. It supports custom PNG files uploading, and it doesn't need to run in headless browser. It just accepts HTML, CSS, and JS files and renders them in their cloud. Yeah, and how native bitmaps look in this pipeline. For example, we have our button Swift component. It has separate build step, which produces button Swift file, actually compiled binary. And for the bitmap testing, we are using our custom toolchain called native renderer, which accept this binary, run it in the virtual machine on AWS, render the actual component, get the PNG file, and return it back to Bazel. And yeah, it produces the PNG files, and it's again depend on the code itself, and we can leverage caching for it. And also, yeah, Bazel not can just test and build your code. It can also run arbitrary scripts. And for example, we have compare function where we can run and see the hub URL in order to compare stuff. Cool. Support common developer experience. For this part, yeah, we want a Storybook-like experience where you can spin up the server and see how components look like. And we also want to accept contributions, and we want to like eliminate any friction in order to run our monorepo. For Storybook-like experience, it's not a popular choice, but we choose to not use Storybook for our components for several reasons. First, it doesn't support custom PNG to review, like preview web and native components at once. Second, it uses its own build pipelines, like you need a separate build and separate webpack configuration for Storybook and so on. And it doesn't fit well into Bazel caching, and it wants to own component built-in, which breaks incremental Bazel caching for each component. And the third one, last but not least, we need to support Shadow DOM rendering for our Grammarly browser extension. But how we develop components then? It's actually a very simple HTML-only multi-page application. Each component should have its own generated on-the-fly playground HTML. Each component playground show all states and substates for the component. And each state and substate produces its own bitmap. So we do not need to like write tests to test each state and substate. It happens automatically under the hood. And yeah, root index HTML to navigate to each component. And yeah, it looks like it. As you can see, it shows two renderers, HTML and Shadow DOM, where you can switch between them. We can also add to the mix native components and so on. Yeah, nothing fancy here. Probably it needs some CSS, but it serves the purpose. How it works technically from the Bazel perspective, we have again our component, we have our build, and now we have a playground target which accepts our component and produces the index HTML file. And also we have another target called dev server, which we can run and get actual URL which serves our index HTML, which includes our component. And as you can see here, as a benefit of this approach, we can even run only one component dev server, and it's very nice in terms of scaling, where you have an enormous amount of components and you need to develop only one and do not need to touch and compile and build anything except one little component you want to work on. For our Happy Path, since Bazel actually manages everything, the only dependency the developer needs is Bazel. Actually, Basilisk, which kind of like node version management, but for Bazel. And on a free repo, you can just run one command and it will do a following. It will download the correct Bazel version. Bazel will download correct Node.js version. Node.js will install node modules. Bazel build only needed targets and use cache if it's available. And yeah, Bazel runs Storybook-like page for you to start developing. Some statistics from my MacBook and our M1 Mac Mini runner on CI. Running Storybook-like server to start component developer with cache like almost nothing, less than a second, without any build cache, for example, TypeScript version updated 55 seconds. Our full CI pipeline for web, macOS, and Windows, build, test, deploy, and bitmap conversion take like 1 minute, 16 seconds with cache, and without cache, it almost 5 minutes. Potential benefits. what we can do more. We can migrate from the deprecated rules Node.js Bazel one to rules.js. It will improve IDE integration and downloading NPM packages. We can also enable Bazel remote caching and reuse local machine cache on CI and vice versa. Yeah, it needs same architecture on your machine and CI, but still it is possible. Yeah, we can only use TypeScript for compilation for DTS files and not for everything, and use, for example, SVC instead of DSC. And yeah, add some CSS to our Storybook. So as a conclusion, what we get a single code base for all platforms. We get single command to start contribution, and we get 1 minute to build, test, and deploy and publish our multi-platform design system. And yeah, that's basically it. Maybe you have some questions.
Just a reminder that we have a Q&A tool, and you can ask your questions there. Okay, so we have one question. Why Hapo.io, and how are you using it?
Yeah, we actually, yeah, thanks for the question. We actually explored a lot of tools for bitmap comparison and reviewing our components on CI. And yeah, the main reason for Hapo is that it have the REST API, so we can write our own wrappers on top of it in order to compare the native macOS and Windows components and the web one. That's actually one of the biggest benefits. Of course, yeah, there is a price question itself and so on, but the main one is this HTTP API that we are using to compare screenshots between platforms.
We have one more question. Why have you chosen Bazel instead of Lerna or other tools?
Yeah, thanks. We actually used Lerna before Bazel in one of our repos. And the main reason for Bazel was that we need to support native tool chains. Like we need to write a Swift code, we need to write .NET code and C#. We need to write Java code. And if you will put, for example, I don't know, Swift scripts into package.json to build Swift and publish it, and then for MS build and then for Java and so on, it will become a mess at some point. So probably if you do not need to support native tool chains, then probably, yeah, you can just use Lerna, PNPM, Yarn workspaces, whatever you prefer from the JavaScript world. But in order to build like multi-platform stuff, it's probably better to invest into Bazel.
Okay, it seems like we have no other questions, so we can proceed. Losha, the stage is yours now.
Thank you so much. Thank you, Ostap, for great presentation. Share my screen. Okay. Hello, everyone. My name is Levzhynskyi. I'm a tech lead of browser extension team at Grammarly, and today I'm going to talk about the web security, secure web software development. So basically the agenda is we will talk about some problem statement, basically why we should care about it. We'll just see key vectors of attack to web application on some examples, and we'll talk about how to protect, and basically there will be some summary. So let's start. So first of all, why we are talking about security at all? Why in web development? So first of all, it's about user trust. So users trust their data, their information for us, and we should be extremely careful with handling this information, with how we are storing, transferring it through the wire. So basically, yeah, it's very, very important. So any even simple leak may ruin the reputation of the whole web application, and no one will use it. So yeah, and what basically probably one of the main goal of thinking about security, if it for sure is protect users' data, for sure we're also thinking about our infrastructure, our personal data, like the web developers and other stuff. But yes, the first thing is that we should the first thing that we should think about is basically how to properly handle users' data. And just to be on the same page, what is the user data? So usually we can split it into kind of two kinds. The first one is a personally identifiable information. This is usually a combination of some informations that can be used by hackers to track the user activities. It's like name, user ID, the age, the location, some for sure login information that will allow someone to log in on behalf of another person. And usually this is someone need to know the combination of this data. So user ID by itself, might not be very sensitive information, but in a combination with, let's say, IP address, it will allow to track someone's activity. And for sure, it's also about the kind of second part is actual user data, like text, comments, some calendar events, whatever user produces. So when we are talking about security, we are thinking how we are handling this kind of information. And then let's check some pretty common vectors of how someone may attack the web application. The first one is pretty common, it's called SQL injection. Nothing special here. It might not be common for someone who's not working on SQL, but it's still a lot of web application based on SQL, like someone uses SQLite built that runs in the web application, or someone storing data on the backend. And let's see on some example. Unfortunately, before we will switch to example, unfortunately, it's still relevant for some cases, especially if someone going to implement SQL like SQLite manually, locally in browser. So here is example. Here is a pretty simple application, sort of toy example, note-taking application. Someone can go ahead, kind of log in and create some notes. So the first one is the home screen. It shows our personal notes. The user is Jane, and there are two nodes. This is my first node and second one. So here is a kind of basic functionality. Someone can go ahead and search it. The thing is that under the hood, we are using SQLite storage. Basically, it's implemented with WebSQL. For sure, WebSQL, just for the demo purposes, WebSQL is kind of deprecated. So most likely on the real project, you will use SQLite or SQL storage on the backend, but the thing is pretty simple. Someone can go ahead and search. Here is a SQL query that's been used to query this data. And you may see we're just doing a simple select from table nodes with some additional information. It looks kind of basic, but for sure there's someone who going to try to hack us, may do a sort of SQL injection. And basically, this person may go ahead and type and use pretty common pattern with OR and type some specific data, and basically this will allow to query all information that is stored in the database. And basically the user Jane may unexpectedly get the personal notes from John. For sure, it's not secure to store your personal passwords in any custom node taken up. Please use secure storages. But anyway, this is how a SQL injection looks like. Yeah, that's it. Most of how to basically just couple words how to protect. For sure, don't try to construct the SQL queries by yourself. Use DSL, use libraries. Usually, a lot of libraries provide a way how to escape this data. It's the same probably like with regex. You may do the same. You need to escape, and you need to be careful. But yeah, it's still possible. Moving on. Another one is a kind of funny thing, but it's also possible to create sort of CSS injection. It usually works. I'm not going to show any demo. I will later on. You can go ahead, open this link, and see a pretty huge article for 10 pages on how it can be basically how someone can hack with CSS injection. But the thing is that here we the hacker injecting the specific CSS to track the user inputs. How does it work? So there is a CSS rule that allow to match input with specific value, and basically when user types, the CSS will automatically execute some rules and will kind of try to show the background from a specific URL. For sure, this URL will lead to some hacky server that will just trace this data, and by these traces, someone will be able to, I don't know, maybe get the password. It's hard to imagine how to use it in real life, but anyway, it's possible. So also please be careful with all this CSS and GS when maybe you will allow to, I don't know, just inject the custom colors with additional meta information. And the most common probably nowadays the most common thing is cross-site scripting or XSS. So basically, the thing is the goal of this attack is usually to somehow inject the hacky code into the original site and trick and basically inject it and execute on behalf of this on behalf of this site that's been attacked. And in most cases, it's just to trick the user and make the user believe that this code is executed on behalf of this site. Let's see an actual example. It's still a node taken up. Here is a page that allows to manage some nodes. Developers who developed this site, this to example, this had a kind of task to make to allow to use a formatting for the nodes. So basically, this is my third node. Basically, so basically, user can go ahead and format their nodes. Nothing special. It kind of looks pretty simple, but developers didn't have much time, wasn't care about the actual security, and kind of allowed to insert the code as is. And more to that, developers decided that okay, we need a quick way on how to create the nodes. So would it be great if we will use some, let's say, n query parameters that will allow to directly insert and create the nodes. So basically, and some hacker decided, what if I will pass a script, and in this case, this script will be evaluated as is, because we are not doing any kind of any filtering. We are not validating what's here. We are just inserting. First of all, here is a query. We are just inserting the value as is into the database, and then we are just inserting into HTML. So it's been executed. This is kind of looks pretty simple and obvious, but one more time, be careful when you are working with a sort of content editable, or you are not processing the user inputs. Okay, and most of cross-site scripting are impossible without actual social engineering. So basically, someone first need to trick user to open this kind of hacky URLs that contain some additional data or maybe perform some action. Here is on this slide an example on how someone trying to pretend that they are a CEO at Grammarly and trying to steal probably some information. But nowadays, all services, this is a message from Gmail. So most of services trying to somehow use heuristic to detect some phishing and social engineering attempts. Okay, and we just checked the most common things. They may look obvious, maybe everyone already heard about them, but still they can be used on some site even nowadays. Okay, how to protect? Some basics. So first of all, think about the user's data and think on how you are processing and basically send it only to trusted servers. So what I mean, you most likely you are okay to send this data to your own servers to store it, to process. But do remember to use a secure connection, whether it's HTTPS or a secure WebSockets connection. Be careful with third-party login service. So it's not always okay to send the user data to this third-party logger like JS or web login because you cannot control this data, and this data, like user's data, may be leaked by another site, not by you, but by your servers. But it's kind of still a security leak. Like we saw with cross-site scripting, all these examples, don't inject raw users' data as is. Index HTML especially, kind of sanitize it, double check, do a post of pre-processing, and couple words about the get. This is more like a client-server communication, but unfortunately, this is pretty common mistake in web development. So don't use GET requests, don't use query parameters to transfer any tokens, any login information. This is really dangerous because even with HTTPS, all such requests can be kind of tracked or observed by someone, by some proxy maybe, or someone in between user's PC and, I don't know, ISP, the internet service provider. So for all these cases, please do remember to use POST, because in case of POST, all this private data will be transferred in the body of the post, and it cannot be tracked with HTTPS. It cannot be tracked when someone just observes or sniffs the HTTPS traffic. And couple more rules or maybe suggestions on how to protect and how to work with incoming data. So first of all, do remember to validate and escape any incoming data. There are a lot of libraries that provide some guards on client guards that will kind of validate this data. One of examples is to use IOTS. On this code snippet, we are creating a guard for the interface card. This is TypeScript, by the way. We are creating the guard for interface card, and here we are explicitly saying that this interface should only contain card ID, and it should be number, and the kind should be card. On the last line, we are doing the decode. We are decoding the incoming data, and basically this data going this actually JSON or object going to be dropped because card ID is not a number and kind is not a card but rather random. By the way, IOTS provides kind of types for these guards, for this interface, kind of out of the box, so you don't need to duplicate this boilerplate. You should just need to the specific type of function, and you will get the type that can be used with all other TypeScript code. Another thing about the user provided HTML, So there is a great tool called DOM Purify. So the rule of thumb of using this DOM Purify is remove all script tags and remove any URLs in CSS. So like we saw before with CSS injection, someone may try to use like CSS, like background URL, just to track the user activities, like tracking pixel, but sort of it's better to remove them. And for sure, better not to inject any HTML, any raw HTML, use I don't know, some frameworks to generate this data. Now, for sure, it's not always possible, especially when you are developing some rich text editor or you are processing the user paste events. But anyway, try to avoid it. If you cannot, just sanitize and remove all suspicious or potentially dangerous parts of this HTML. And one more thing about the query parameters, it's somehow related to the GET requests, but also do remember and treat all incoming kind of query parameters like so potentially dangerous. So do the same, apply the same rules, sanitize and validate them. Many years ago, we had a pretty pretty interesting case. Ethical hacker, we're using the ethical hacker service for manual testing. I will talk about it later on. But anyway, they explored our editor and basically found a pretty interesting security issue, I would say. So it's pretty common when someone develop a web application to expose some maybe dev API or maybe some tools that allows you to somehow tweak or slightly modify the behavior of your production application. And the usually common thing is to use the query parameters. So basically, in this configuration, you may tweak, I don't know, the speed of response, the bounds, some timers, whatever. But also, we had one part that allowed to update the URL of some specific buttons on the page. And unfortunately, this is not secure because someone may create such config with custom URL and ask some users through the social engineering to open this page and maybe somehow tweak it. So user will think that it works with the original site, but in the fact, under the hood, it will be somehow hacked by and altered with unsecure links. For sure, there are some other ways how to protect from it, but yeah, the solution is don't use query parameters in such a way. Also, don't allow in production to update any sensitive parts of your site. So the solution was extremely simple. We just removed this configuration. Originally, it was used for testing, but yeah, we're using it only on QA. One more thing about the how to protect your sites, and basically something that usually missing maybe it's content security policy header. It's a very powerful header. It allows you to first of all to protect your site from opening in the iframes. Let me show a quick example how it may look like. For example, we have here it is. We have our note-taking app do have an upgrade to premium, so definitely we provide some premium functionality, and someone decided to tweak users. So how it can be done? So basically, someone can create the same the site with the same domain, or maybe not kind of exactly the same, but with a misprint in some symbols, and basically to use a frame to open our original the proper one, the secure one domain, and use the overlay and put the overlay over this iframe. So when user may think that it works with original note-taking application, but basically everything, every click, every interaction will be intercepted by overlay or by some custom logic. for sure, here is only clicks, but theoretically somehow we may, I don't know, some hacker may, I don't know, render another button over it or whatever. And in general, user may kind of still think that it works with the original one, but it's not. One more thing about the content security policy. Also, it may protect at least partially, maybe, from cross-site scripting attacks. Because in content security policy, you may specify exactly domains from where the JavaScript is allowed to be executed. Also, you may forbid to execute inline JavaScript or even inline styles. Okay. This was more about some actual real practices, but also there are a lot of toolings that allows you to ensure that your code base is somehow secure. There are some tools like Renovate or Dependent Bot that do scan your projects and detects the potentially insecure dependencies and even make automatically create a pull request, merge request, and update them. Also, there are a couple of linters that allows to spot the basic issues with your code, especially with the issue with no opener and links. I'm not going to talk about it in details, but here is the link. You will then be able to open it and check what this issue is about. Also, almost all CIs do have a security scans, like GitHub, GitLab also provide some security scans, and if I'm not mistaken, GitHub do have an integration with Dependabot, pretty good integration. And for sure, there is always a free tool called NPM Audit that allows you to just check the state of dependencies of your project. Unfortunately, not everything can be covered by tools, because security, someone may make a mistake in pretty non-obvious place, and that's why it's better to also use some sort of manual testing. We are Grammarly using the HackerOne, like for ethical hackers to test, but actually not test, but they are trying to hack your code. And because we here for more than 5 years, and basically we found the collaboration with HackerOne is pretty successful. For some bug bounty hackers trying to hack our servers, our web clients, trying to figure out how to avoid our security protection, and it works pretty well. So like I showed before, they found a pretty interesting issue with our code base, and we was able to fix it pretty quickly, because by default it's kind of test, it's private first. Also, here are a couple of reports. I would encourage you to go ahead and check how hackers think and how they are trying to break your web application. So it's pretty interesting to see the kind of another view on the web development. And the one interesting thing, at least for me, is that the obfuscation or minification, it doesn't really help to kind of somehow hide the security issues. It's extremely simple to unminify, unobfuscate, and explore the bug and figure out how your application works. This is basically the example that I showed before. There is it's public. There is a pretty detailed explanation on how the hacker was able to basically debug and how they found the actual issue. So please go ahead and check them. And so basically that's almost it. Sort of summary and or maybe lessons to learn. So first of all, I would encourage everyone to learn at least basic security practices in your area, whether you're working with a web part or server side, or you're kind of full stack. So think about, learn about some basics, so you will be kind of aware of potential issues. So especially if you tomorrow will decide to use WebAssembly and SQL on your web page. Introduce the security into the process of development, so it should be a part of day-to-day work. The same for tooling. Before, why it's important? Because yeah, for sure it's simpler on the early stages to figure out the potential issues and not maybe, but somehow protect or fix them. Kind of, if you're going to work with, you're going to build a rich text editor, or if you're going to work on some service that will store logs, so you need to think at the very beginning how you're going to store this data, whether it will be encrypted, who going to have access to this data. So basically this may first of all, this will protect your web service from leaking data, but on the other hand, you will also see the actual amount of work that's needed for some specific server. And yeah, kind of rule of thumb: protect yourself from social engineering. Do not open any suspicious links. Do not help hackers. So think wise. Here are some useful links about some stuff that I mentioned in this presentation. My part of presentations, there is links that explains how CSS and JS may be dangerous, how to use content security policy and other stuff. Yeah, thank you.